Hello, welcome to Chapter 3, Section 3, Solving Systems of Linear Inequalities. In this example, we're going to have a system of more than two, and we're going to see what's going to happen. This system, with all solid lines, is going to create a geometric figure. It's going to create a polygon. So we're going to also identify what that polygon is going to be. This is leading to the next section, where we're going to have a system with lots of inequalities. These are called constraints, and it's going to result in what we call a feasible region. So remember that when we get to the next stuff. This is going to help us with the unit project that we have here. All right. So I already talked about the fact that we're doing solid lines for everything. Let's talk about y equals 5. Y equals 5 is a horizontal line at where y does equal 5. So I'm going to draw my horizontal line from one side to the other. Could have been a little bit better freehand, but it's okay. I want the y values that are less than 5. So shading above would be greater than 5, shading below is less than 5. So I'm going to make my little marks here like this, because I know I've got 3 others to graph, and I'm not going to fill in my graph yet with a bunch of lines. Next inequality. My boundary line is y equals 2. Solid, so here's my y equals 2. And this tells me I want my y coordinates of my inequality to be greater than 2. So I'm going to be shading above this. Now check this out. These two together actually do this. 2 is less than or equal to y is less than or equal to 5. And if I do Desmos, go back to this one, 2 is less than or equal to y is less than or equal to 5. That's given me this area on the graph where all the y values are 2 or more, but they're less than or equal to 5. So all of this red area is the space that's between those two. This is how we have to do it on Desmos. All right. You can do it separately, and actually, tell you what, let me show you that. Okay, so that's that. And then if I do, what was it, y less than 5? Yep, y less than or equal to 5. So look what happens. Now I've got like the whole thing shaded, and because I've got like the red up here and the blue down here, it's this overlap, the purple part right here in the middle, that represents what I just had a moment ago. Okay, so by putting them together, it kind of helps eliminate all the extra stuff, right? Keep that in mind when you're going to be graphing these with Desmos. I'm going to shade in between it like that is, but first I got to do these two. My boundary line is y equals 3x plus 1. My y-intercept is 1, which is right here, and my slope is 3. That's 3 over 1. So I'm going to go 1, 2, 3, right 1. 1, 2, 3, right 1. 1, 2, 3, right 1. And I'm also going to go 1, 2, 3, left. 1, 2, 3, left. And I'm going to keep doing that until I go off the grid. And this is also a solid line, so I'll try to draw it carefully. For the last inequality, I put it right here. The boundary line is y equals 3x subtract 4. My slope is still 3 over 1. This time my y-intercept is at -4, which is right here. So I go 1, 2, 3, right 1. 1, 2, 3, right 1. And that, I could keep doing that. That's going to go this direction. Now notice what I have here. I want to be less than this line. So on this side. And I want to be greater than this line. So the end result is this area right here. It's below this horizontal line on the top, above this horizontal line on the bottom. It's below this slanted line and above this slanted line. And this shape inside here is a parallelogram. Now this is where Desmos, sorry, my screensaver kicked on. Put in the wrong code. This is where Desmos gets a little confusing, right? Let me move that over so I can see what it was. So you're going to have to outthink the technology here just a little bit, and I know that that's sometimes difficult. 3x plus 1, and then y, oops, hit that too many times. Y is greater than or equal to 3x. Like I said, I don't like using this keyboard. Subtract 4. Okay, now look what happened. Let me unhighlight that. This is that parallelogram that I was just talking about right there. And of course, it looks really, really difficult with having all those in there. You can do it this way, all right? I'm not saying you have to, but you can do it this way. You can do 3x plus 1 is less than or equal to y. So I turn that purple one around, which is less than or equal to 3x. Actually, I think I did it backwards. Yeah, I'm sorry. I did the wrong one. Minus 4. 3x plus 1. Okay, now let me get rid of these two so you can see a little bit better. Okay, so now see what happened, right? By putting the boundary lines on the other sides of the y's, it allowed me just to graph in between these, like I graphed in between here. You can still get around it a little bit by changing this and graphing it to where I'm only going to shade from here to here, and then I have to go from here to here, and then from here to here. I have to do it like in pieces, but I'm not going to get into that for this one, okay? If you saw my my artwork for Desmos, then you'll see that that's what I've used because I didn't want all the extra stuff. All right, so that's how we do that with Desmos. I'm going to do another one by hand, and then we'll get to the guided practice problems, okay? My boundary line is x equals 6. Solid, solid, solid again. X equals 6 is going to be a vertical line that goes through 6. And since my inequality says I want the numbers, the x's that are less than 6, that means I'm going to shade on this side. So I'm just going to put little marks right here just to say, yeah, I'm going to go to the left of that line. My boundary line for the second one is y equals 1/2 x plus 1. My slope is 1/2 and my y-intercept is 1. So here's my y-intercept, and my slope tells me to go up and to the right, up 1 and to the right 2. So up 1, right 2. Up 1, right 2. So it goes like this. I can also go down and to the left 2. And that's going to look like this. All right. So, again, solid line. So I'm going to draw a solid line through here. And I want the y values to be less than that line. So I'm going to shade below it. Now, like in the previous videos, I would know that this is the overlap. But I've got one more boundary line. My boundary line is y is equal to negative 2x plus 4. My slope is negative 2. I'm going to make it into a fraction. And my y-intercept is 4. So here's 4. And negative 2 tells me to go down 2, right 1. Like that. And one more time, solid line. and I want to shade above it. So I'm going to shade above right here. So if I'm below this line, above this line, and to the left of this line, that tells me that this area right here is my overlap. And that appears to be a triangle. But I'm going to give you a little bit of bonus for this one, okay? The slope of this is 1/2, and the slope of this line is -2. -2 times 1/2 equals -1. If the slopes of two intersecting lines are opposite, one positive, one negative, and reciprocals, and when you multiply you get -1, that means that they are perpendicular to each other. So not only is that a triangle, it is actually a right triangle. All right, we'll see you in the next video.